Good evening, everyone. I welcome you all for the session 2 of today's event. I wholeheartedly welcome you all for today's session 2 event along with our chief guest. A special welcome to our chief guest Prabhu Balasubramanian sir. He is a full stack developer with cloud and DevOps expertise. He is having overall 17 years of experience in full stack developer, DevOps practice, cloud, SRE, Agile, SDLC, enterprise application development, database, infrastructure automation with a technical background. He is possessing extensive hands-on experience and passionate working in Java, J2E, Spring Framework, PHP, CI/CD pipeline, Docker, Kubernetes, AWS, and Azure DevOps. He played multiple roles such as developer, tech lead, technical architect, manager, senior manager, agile BA, and Scrum Master, product owner as and when a product needs. He is having experience in cloud migration, adaptation, IaaS, PaaS, SaaS, cloud computing delivery models, and deployments in private cloud service. He is a self-driven DevOps engineer with hands-on experience in DevOps tool chains, also vulnerability scanning and management, also tracking and application security. He is exploring AI, cybersecurity, and bot technologies also. He is having experience in managing infrastructure as code, Terraform, AWS CloudFormation, and ARM templates. He is implemented POCs based on client requirements in collaboration with pre-sales team. He is a good leader who solves a problem by brainstorming and delegating tasks with open discussions and very much dedicated to customer centricity with a high reputation. He is possessing knowledge in various domains, including banking, finance, healthcare, insurance, and telecom. He is familiar with business analysis, incident, impediment, release, process, people management, test driven development, and agile waterfall methodologies. He is possessing ability to learn quickly and prioritize the task, also influence technology driven solutions. We are truly honored to have such a personality today as a chief guest of this session 2 of day 4. Thank you very much for your presence today with us, sir. And now I hand over the session to you, sir. Thank you. Please take over the session, sir.
Thank you, ma'am. Thanks for giving such a long introduction to me. Thanks, Uma Mangeshwari, ma'am. Thank you, Department HOD, sir, and Principal, sir. Thanks for giving such a good opportunity to me to share about big data tools and technologies. Yeah, I would be happy if you ask more and more questions to me at the end or middle. Then you just stop me. Then we can discuss it. Then we can move forward. Can I share my screen? Ma'am, can you please confirm? Are you able to see my screen?
See you, sir. Now only this you have started to share your screen, sir. I'll check and say immediately, sir.
I shared. Are you able to see?
Just now it started to share, sir.
Okay, okay. So now you can see the first slide. Uma Maheshwari, ma'am.
Sir,
Are you able to see my
no,
first
sir.
slide?
No, sir. No, sir. Still,
Oh,
it is loading like started to screen
okay,
sharing.
okay. 1 minute.
Sir, now it is clearly visible, sir. Please carry on
Okay.
your session, sir.
Thank you, ma'am. Yep. Today we are going to discuss about big data technologies and tools. So if you want to connect with me, then you can follow this LinkedIn page, Prabhu-Balasubramanian. Yeah. So today we are going to discuss about what is big data technology and why, and what are all the ecosystem of big data, and then its framework, product, and famous tools, and then what is maybe data visualization on big data, Tableau, Hadoop, and then what are the job roles available here. Then how to install Hadoop, and then we can see the demo at the end. Yeah, here. Now, what is meant by big data? So each and every day we are uploading a lot of images, photos, videos, and then we are sharing text messages or emails, everything we are sharing it to other one, or we are uploading to the particular website or anywhere, any product, right? So it creates it creates a lot of structured, unstructured, semi-structured data. So each and every day, the million and million of data it will be creating. We are creating. So now it's too difficult to handle extremely large unstructured and structured data. So it's too complex to handle it. So we won't handle it in the traditional way. So how do we handle it? So we need to go with modern technology like Hadoop and Spark, something like that. Okay. Now, what is meant by volume, velocity, variety, and then veracity and value? So these things are all very important before we are going into the big data technology. So big data in the sense it's too big and then too fast. So too complex to handle it. As I said, so it's extremely complex set of data we need to handle without Hadoop or Spark or modern technologies. So here we need to find, we need to understand what is going to be volume. Volume in the sense amount of data. So okay, each and every day we are creating or we are uploading and we are sharing all the text messages and then images, photos, as I said, and then including emojis as well. So its amount of data is huge. What is maybe velocity? Velocity in the sense it's a speed of data. For example, now consider share market trading. So each and every second they are changing their data, right? So it's too difficult, too complex to handle this kind of data. And then like some other cryptocurrency related sites, so every second they are changing their cost, and then everything they are changing it based on their input. We are changing, they are changing the cost, everything, product, and then your amount of data, right? Variety. What is my variety here? So different type of data, like GPS related data, and then data sensor related data, and then as usual, images, photos, messages. Then what is my veracity? It's a kind of, we need to check whether it's true or false, like trustworthiness of data. So a lot of data we are sharing and we are having and we are viewing, right? So we need to check whether it's true or fake. So we need to check the quality or accuracy of the data. It's called veracity. What is meant by value? So based on our search or our input, lot of companies, they are trying to give their suggestions or their recommendations to us again. For example, now we are searching or we are discussing about something, then by default it captures Google. Then based on our input, it's suggesting the videos or text messages, right? It's called value. So this understanding is very important before we are going into the big data. So these 5 V's, we need to get the clear idea, then we can get the clear idea of big data. Okay, here, why big data matters. So nowadays we need to handle this kind of data, then the cost is too high because our service is not enough to handle this kind of big data. For example, now consider uh, in the court activities. So from complaint to judgment, lot of activities are there. So it contains each and every case result more than 1,000 pages. So per day, minimum lakhs of judgment we are receiving it, right? So then consider it's a billion of document they are having it. So how do we handle it? So we are following the normal way as usual, traditional way. Then the cost is too high, and then time is, it takes a lot of time to understand. For example, now we need to check particular judgment. Then how do we handle it? Because everything, it's a document. There is no we are giving the particular date or particular sentence, then it will search the entire um, page or entire judgment related concept. So it's too difficult to get the data, proper data. So these things and all, it's a complex of big data. Then we have to go with our modern technologies like as I said, Hadoop or Spark. Then we can handle these kind of things. So we can save cost, time, and then all other benefits. Okay. What is maybe big data ecosystem? So I know you guys are using Apple, right? So Apple, once you move into iPhone, then MacBook, and then iWatch. So these things and all, once it's collaborated everything, right? So once we configure it anywhere, then we can use like other system. Like we can use more, phone in the MacBook and then iWatch. So everything we can, it's collaborated, right? So the same kind of concept we are using here. Now, we here we are segregate into 5 different topics for big data ecosystem. So the very first thing, so all our data we are searching into our social media. For example, I'm sharing it. Social media in the sense Facebook, Twitter, and then YouTube, whatever we want. So we are uploading, and then we are viewing, and then we are searching everything we are doing in the data sources. So it's data source. Then we are extracting, transforming, and loading into the particular structure or unstructured way using Spark or Plum. Then it will be moving into the data warehouses like HDFS and then HBase here. So we'll see later what is meant by HDFS, HBase, these things and all. We'll see it later. So basically, once extracted, then it stores those data. Okay, once stored data, BI tools, it analyzing and fetching, it moves into the visualization tool. So the visualization tool, it gives the structured dashboard to view the data. Okay, data storage technologies here, Hadoop, Flume, and then Hive, Spark, Kafka. So these things and all supported data storage technologies. I know you guys know very well about RDBMS and then NoSQL, right? Anyone please share about what is meant by RDBMS and then NoSQL? Anyone? Guys, are you there? Okay. So here RDBMS, it means it's a structured data. We are storing the structured data. It's the rows and columns. And the NoSQL means it's a semi-structured or unstructured data. It's a document type. Okay. Distributed file system. So we are storing the data across many computers. Okay. Then it's called distributed file system. We are using HDFS here. Um, then data lakes versus data warehouses. What is meant by data lake? What is meant by data warehouses? Here, data data lake. It means we are. I mean, it's a kind of raw data. It means what's meant by raw data? It contains both unstructured and semi-structured data. We are storing it to the data lake. For example, Amazon S3. We are storing lot of unstructured data, and then the speed is bit slow, but cost wise it's very comparatively it's less. It low cost. But data warehouses means it's a processed and structured data. For this, we are using HDFS. Okay, HDFS means it's a Hadoop distributed file system. So we are Hadoop fetches and then stores their data into the HDFS storage system. Data processing framework, batch processing, Hadoop, MapReduce. Here, what is meant by batch processing, MapReduce? For example, now we need to search data, or okay, in the simple example, we can say now we need to count a word of book. So book contains lot of pages, right? Per page, lot of words are there. So now, what is meant by map reduce? Map. So we divided into two part. First part map, second part reduce. Map in the sense it divided big task into the small task. For example, now we need to count the total number of word of book. Now map, what it will do, it counts page wise. So based on, so each page it gives a count of word. Reduce, it collects all pages number of counts and it give the consolidated result of the count. Okay, so these things and all batch processing, stream processing. So now we need to share our input from one end to another end. We are going to receive another end. For example, now we need to pass our data from one framework to another framework, or one product to another product, or one our product to third party system. Then we need to use these things. Then they are getting the same data quickly. Yeah. Now here, data storage, data processing, and then first we need to collect the data, then pre-processing, then we need to store. Once stored, we have to analyze the data, then finally we are going to the visualization of data. Okay, so here sources of generation. So here all email, cell phone, GPS, everything, data sensors, everything is here. Then data, it three different format is there. One is structured, another one is unstructured, and then semi-structured. Okay, so third part, data processing. So once stored, structured or unstructured, then it will be fetches the data and store into their own distributed file system. Then it analyze. Then finally the data visualization part. Okay, Hadoop ecosystem. As we discussed earlier, HDFS, it's a storage mechanism for Hadoop. It's used by Hadoop. Then MapReduce, already we discussed. Then what is meant by Hive here? See here, Hive. It handles SQL query. It means it handles the structured or processed data. Okay, HBase. It handles unstructured data. It means no SQL. Okay, what is meant by pig? It's a scripting language. So we need to get the data and we have to store, we need to view the data from the HDFS. Then we need to use pig. Then yarn. Here, this one is the resources manager. So how much CPU memory we need to give that things and all in Hadoop, yarn handled it. See here, HDFS, then yarn, MapReduce. So here the top layers, pig, hive, H catalog, HBX, these things and all. Apache Spark. Okay. Uh, so here both Hadoop and Spark developed by Apache. Both Hadoop and Spark are open system. Open source. So what is the purpose of? Okay. What is the difference between Hadoop and Spark? So both are open source. Both are developed by Apache. Both are used to handle big data. Then what is the difference? So the big difference is Hadoop handled file system data. Now we are fetching the data and store it into our hard disk and then file system hardware. Then it handle and process and it moves into the data visualization tool. But Spark, it handled the data in memory. Whatever the data is available in RAM or we are move our data into RAM, then Apache Spark handled it. Then here, comparatively, Apache Spark is too quick, like 100x fast comparatively Hadoop. So here it handled ML, SQL related steps, but Hadoop handled BI tool reports, dashboards, and all. Okay, data injection tool. Apache, Apache, sorry, Apache Kafka. 1 minute. Data injection tool. Here, Kafka and then Nifi, data integration with API connectors. So here these things and all. A real-time pipeline. Kafka, we need to consider the real-time example, as I said, in the trading, share market trading related mechanism. We are going to pass the data from one end to another end. So then once they are moving into the data into their server, we are receiving within fraction of second, right? So these things and all, they are using the Kafka or Flume. Here, data integration with API and connector. So these things and all, say injection tool. No SQL database. Okay. What is meant by no SQL? How do we handle it? So there is no structure. So everything stored into the document format, right? So now we can handle it through MongoDB or HBase or Cassandra. Okay. So here we have very less time, so we can skip these things and all. Okay, data analysis and visualization tool. Okay, what is the purpose of data analyze and visual? So if you want to see particular data, then we have to, for example, now you are searching the particular images. Then suppose it will give some irrelevant images or irrelevant text to you. Then uh, second time you won't use that particular product or website, right? So before we are giving anything based on your search text, we have to analyze it. Then finally they need to the visual in the proper structured format, right? So that things and all, Tableau, Power BI, and Kibana, these things providing the good data analyze and visualization tool. Okay. Now, machine learning on big data. So ML libraries, like a few libraries are supporting the ML, Spark, MLib, and then TensorFlow. These things and all. So, recently, they are supporting into the ML related big data stuffs. So we need to find the fraud, I mean fake data or unauthorized user. They are something they are searching or they are doing something. Then we can use these libraries. Okay, data machine learning, domain model, intelligent futures. Here, data, for example, here we are sharing big data plus machine learning. So here, ticket history, and then now we are going to book a ticket in the IRCTC, and then it contains a lot of history, right? So based on that history, we are fetching the data, and then again it checks whether it's a relevant data or irrelevant data. It's continuously recursive way. It checks based on their algorithm. Then it move the recommendation engine. So and, we are doing the same process again and again. Then based on that input, they are suggesting the uh, shortest path and then our very minimum cost travel recommendations. So cloud platforms for big data. So the major platforms, AWS, Google Cloud, Azure, here they are supporting the big data. Here, as usual, the same scalability and then fault tolerance, high availability, these things and all. By default, it's supporting Azure, AWS. So here you can see the big data terminologies here. So based on this terminology, against this terminology, Azure services, you can see the Azure services. For example, data visualization. Then, based on our big data terminology, data visualization in Azure, you have to use Power BI service. Here in AWS, you need to use QuickSight. So the same way, you can compare it. Big data use case and real world application. Here, um, any e-commerce website like Amazon, Flipkart, uh, and then any sites or social media, Facebook, Twitter, or Insta, you can uh, check the same big data use cases here. See, big data use cases. First, we need to optimize, then analyze, uh, then we have to predictive support, then fraud, security, industry specific. So these things and all few use cases for big data. So here we can see whatever in real world, real time, whatever we are using and we are I mean, in digital world, whatever you are doing, so everything it's a kind of big data use cases. Popular big data products and tools. Here, few technologies you know very well, Hadoop, and then Hadoop MapReduce, and then HBase. So these things and all, it's a major technology for big data, major and popular big data product and tools. Then analytics like data SDA, then Cloudera. Okay, what is the difference between Hadoop Cloudera? Hadoop and cloud era. Here, Hadoop is a open source, but another company, they are taking this Hadoop. On top of that, they are implemented some other features as well, and they are providing it's a commercial one, like Mac. So they are taking the Linux, then on top of that, they implemented a lot of additional features, right? So here, operational infrastructure, and then infrastructure as a code, see Amazon Web Services, and then structured database, Oracle, and then where is unstructured? Okay, data as a service, then log, vertical apps, all AD media apps, and then business intelligence, Power BI. So it got missed. And then visualization tool. We can see the Tableau here. Big data challenges. So here, when we use big data, then definitely we need to face few challenges. Uh, so when keep on increasing the data, then definitely one point of time we are going to face issue. So incorrect integration. We need to add or append or merge in the proper way, or definitely we need to face few issues. Security and privacy, and then lack of expertise, data verification, and then heavy expenses. So these things and all, a few challenges nowadays we are facing on big data. Future trends like edge analytics, augmented analytics, blockchain, real time, and then collaborative, so ethical, AI powered analytics. So these things and all, few future trends. Definitely AI, ML powered analytics will come in future. So I stop here. Anyone having any query so far?
Sir, after completion of your session, the participants may raise questions, sir.
Okay, okay, ma'am. Got it. Data visualization on big data. What is meant by data visualization? It's a graphical representation of information and data. So it's a combination of art and science. So we need to analyze the data and fetch the data, and we have to give the proper structured and then good dashboard to communicate whatever the information they are trying to communicate. Okay, so few dashboard, when you see, you won't get the proper information. So yeah, we'll see it later. I will tell you how do we handle this kind of data or dashboard, that things and all we see in the next slides. Okay, see, see here, how do we see, like anyone count how many trees are available here? Like 1, 2, 3, right? So 3 trees are available. So it's too difficult to find number 3, right? See here, 5 trees are there, but when I gone through that, we found only 3 trees, right? So whenever the data is there, we have to give the proper visualization, right? So then we have to give the good dashboard. Then you can get the clear input or clear way to express what you are going to do it. See, the same thing. So here, consider lot of Excel data is there, but based on this input, we won't get the proper report of month or particular team or particular product, their sales or our customers recommendations are we won't get anything here, right? But see here, number of months and then how many product sold out and then which month it sold out. So this information all here we can get it quickly, right? Here, data visualization on big data for communicating. Yeah, here, see the previous example, they are sharing into the Excel sheet, right? Here you see the um, US income tier and the 1970s 2009, the values. So the same informations we need to see in the graphical way, then you can get the comparative way. In 1970s, how much, and then 2019, how much. So these things and all, we can see it quickly. Data, how? See, problem. We need to identify the problem. Then, uh, based on the problem, we have to ask query so that we can get better clarity for the problem. So uh, once we identified the problem and we are asking queries and we are getting more data and then we are having a lot of data, then uh, we need to find the exact data. I mean, which data we need and which data is relevant to the problem, and then how do we go to the solution. So these things and all, we need to find the data and then we have to visualize based on that input. Here, dashboard. So any dashboard for big data, we need to uh, give the, see now 100 products are there. So which product is good? That things and all, the recommendation in Amazon, you can see like the rating, right? 4.2, 4.5, and then number of customers. So these things and all, it gives more clarity. And then Amazon choice, they are giving additional label, right? So these kind of information, how they are adding it. So they are checking the quality of the product and then price of the product and then customers review of the product, including package and then price. So everything they are consolidating these data and then they are suggesting or recommending their product in the organized way, right? So this is called the data visualization proper dashboard. Here, example, bad dashboards. Here you won't see here you can see the execute dashboard, but you won't get proper way of what they are trying to say. That information we won't get it properly. But yeah, here the same thing. Here you see the good dashboard. US monthly sales. So this is very high level. Segment sales, state sales, and then when we move cursor here, then we can see state-wise sales, the number of count, that things and all, we can see it here. Here, uh, you can see uh, drunk driving. So that information, so which state they are drunk hugely that information, you can get it quickly. It's a kind of way they are expressing in the way of map and then red dot. So quickly we can get the input, right? See, these states and all very good non-alcoholic guys. So here you can see huge alcoholic guys. So very fraction of second we can get that informations. Here visual ranking within category. Here these things and all it's a final part of big data. So a lot of process are there. Before we are going into the data visualization final part, so a lot of process are there. The data analytics and then storage, HDFS, data warehouse, and then business intelligence. So everything is there. So final part, data visualization. So best practices of effective dashboard. Identify the goal and then design and then um, so keep it visible, avoid chart junk. So, and then 4 C's we need to follow: clarity, consent, and then captivating, and then catalyst. Benefits: enhanced data processing, and then visualize pattern. So within fraction of second, we can get the data. So based on that, we can take quick decision. So the upper level or management level, we have to simplify the complex data and we have to provide the exact data. So better we need to give the binary values, whether it's true or false, something. Then they will take the quick decision, quick manner. Limitations of big data, data visualization. So once we are giving the very minimum information, then it might be misleading the management. So, and then you try to avoid oversimplification. So whatever the data is must, we need to give the data. Okay, don't oversimplify. And then learning curve is too huge for advanced tool like Tableau. Here few is an example of data visualization tool: Power BI, Google Data Studio, and Tableau. Okay. So as I said, Tableau handles data visualization and a lot of use cases. So here Tableau gives fast and effective visual analytics, and then a trusted lot of industry companies worldwide. So we can integrate any third-party applications, not any, most of the third-party applications and workflows to get the data and visualize the data. Here you see the example dashboard of Tableau. So you can check the chart, we can group it. Set. You can see the Excel sheet, right? So it's a 100-time advanced tool of, Excel into 100 advanced tools or options is there, then it's called Tableau. See the Tableau information. So now you can see region America, Asia, Europe. See region, you can get the information. So GDP related countries. So which one is good? China, India, and then Japan, Asia. So within 2 to 3 seconds, you can get the clarity of the data. Different roles: job role, data visualization expert, and then a data analyst. Here, business analyst, and then data scientist. So here, extracting data scientist. So what they are going to do, data scientist. So before that, a lot of job roles are available for big data technologies. Big data technology, we already I said uh, 5 to 6 options are there, okay, including data visualization. And then they need to focus, data scientists, they need to focus extracting insights from large data sets to small data sets. Okay, so basically they need to mm, divided large complex data to multiple small subset block data. For example, now consider uh, library. So there is no rack or no shelves. So all the books we placed into um, one room. Then it's too difficult to get the particular book, right? But the we divided into multiple rooms, and then each room having multiple shelves, and we are placing the book. Then it's very easy to handle it, right? So the same kind of the way most of the guys here doing. So here example job role, and then their focuses, and then their responsibilities, and then example what they need to do. So most of the things are relevant only. So 50 percentage, 40 percentage, it's coming here and there are same. See, a few LinkedIn job vacancies here. Lot of opportunities are available when you can join to data visualization expert or a data analyst or data scientist. Here you can see data visualization tool, current trend. So Tableau, Power BI, and then Google Data Studio. So most of the guys are using Tableau tool. So here Google Trend, you can get the you can compare whatever you want. For example, Hadoop or Spark or any other tool is there, then you can compare here in Google Trends, and then you can get the lot of informations. So which one is popular, you can find it, and then you can get any certifications, or you can learn it. So it will be very useful for your job opportunity. And then demo. So ma'am, anyone having any query before we are going into the demo part? So shall we discuss? Uma Mageshwari ma'am? Or
Yes, sir.
yeah, so I have completed theoretical session. So
Okay,
anyone
sir.
having any queries, then please.
Yes, sir. I'll ask the executive member to
Yeah,
open
yeah.
the participants' mic, sir. Please wait.
Sure,
No, ma'am.
sure.
Already all participants are unmuted only, ma'am. They can directly ask the queries.
Yeah,
Okay, ma'am. Fine. Okay. I kindly request all the participants. You can clarify your doubts or you can discuss any points with our guest now. Sir, I think your explanation is so much clear, sir. Nobody is having any doubt, I think, sir.
ma'am. Two ways we can take it. Like uh, um, we are our explanation or whatever we are sharing, that one was boring or not understanding, then no one asking queries. But which way I can take it, ma'am?
Sir, your
Sir, your
explanation is
explanation
very
was clear.
clear, sir.
Okay,
So we have learned the different roles. We have learned the Hadoop setup. So many
okay.
things, the new innovative things we have learned, sir. Even visualization tools also we have learned, sir. It is very good information we got from today's session, sir. Thank you. Thank you
Thank you,
so
ma'am.
much.
Thanks, ma'am. Thanks, ma'am. Okay.
Thank you, ma'am.
Now we can see how do we install Hadoop, right? So okay, in any interview you can share the information of, first you need to share the information of big data. What it means, we have to handle the extremely large, huge or complex data we need to handle. Then we need to handle in the modern way. Then we have to use the big data technology like Hadoop, right? If you aware of Hadoop, then definitely you can get more confidence any interview related with data scientist or data analyst or data visualization expert, right? Here, so before we are going to do Hadoop setup, you need to understand what is meant by Docker. Docker is it's a kind of a very simple mechanism. Okay, Docker things we'll discuss it later. So if we want to install Hadoop, then we need to install Docker. Then we can use this command to install Hadoop. Then this command will be running the Hadoop image. Then this command will give the all running containers. So here, once you run this, then you can get images, Hadoop images, right? Then here you can get containers. Okay, what is the difference between image and container? Images, it's a okay. We can tell like that. You download any software in your disk. It consider its image. Once after download, you double click it and extract, and you are running. Once the setup completed, then the software will be available in your prompt, right? You can use the software, right? The same way. It's a once installed, then it's called container. Okay. Here it lists all containers. Okay. Then this one we need to go inside the container. Then we need to go this command. Okay. Now we'll see Docker PS. So here I am using Docker desktop, and then see Docker PS. It lists whatever the whatever the available running containers. You can see here. So this is the port it running like Hadoop, right? Now we need to go inside that container. I mean Hadoop. Now you need to go inside Hadoop. Then we need to give the container. So sudo docker ps, it gives a container ID, right? The final last two character F9, right? So docker execute it F9 bin bash. Then we can go with inside Hadoop, right? Here you can see it's kind of Linux terminal, but now we are in Hadoop page, Hadoop container, right? Already I moved a file called sample clean text. Here you can see Hadoop is fun, Hadoop is powerful, big data is the future, something, few words. Now, what we are going to see here, we need to count each word. I mean, how many times Hadoop occurred here, and then how many times big, how many times data. So it count the same word, how many times it's available or not. So here we can 1 minute. So here, HDFS, Hadoop Distributed File System. Okay. Then it creating demo clean input directory. Then we are moving from temp to this directory. Then once we moved HTFC file system, then we are removing a demo clean input folder. Then we have to run whatever the clean input folder contains. That things we structured and move it into the here. Then finally we see the total number of count using this command. See, I will run. See the result. Hadoop 4 times, and then big data three times. Now I will show it to you. How do sample? See Hadoop 1, 2, 3, 4. 1, 2, 3. Here 4. Now VI. See now Hadoop 24. Okay, so this demo got successful. Now we can go with few other examples like sort. So we need to check whether it will be sorting or not. See here, it's sorted ascending order. So capital D, because A to capital D first, capital A to Z first, then small a to Z. So first capital D, then remaining small a to Z. So based on this way, it sorted. Then Now we need to go for search. Search. We sort. So here, using grep command, I searched. So in this file, cat sample. See, in this file, wherever Hadoop is there, it highlighted, right? So we can get the clear and perfect exact data when we use grep command. Okay, sorry, 1 minute late. Anyone having any queries? Yeah, ma'am, I have completed.
Yes, sir. We are waiting for the participants to ask their doubts, sir.
Okay.
I kindly request our participants to clarify your doubts. If you don't have any other queries, we will end up the session now. Okay, sir, there are no queries. We will end up the session, sir. Now I kindly request Banu ma'am to deliver vote of thanks.
We express our heartfelt gratitude to our distinguished guests for gracing our faculty development program with a massive and impactful session. Your profound insights and expertise have been a tremendous asset to our participants, and we are thankful for the time you are dedicated to sharing your knowledge and experience with us. Thank you, sir. Thank you once again.
Yeah, thank you, ma'am. Thanks, friends. Thanks, everyone. Thanks for giving such a
Thank
great
you so much.
opportunity once again. Yeah. Yes, ma'am.
Thank you so much for your valuable session, sir. Thank you, sir.
Thank you, ma'am. Thanks, everyone. Bye.
I kindly request the participants to fill the feedback of session 2 of today's event. Chat box is posted in, feedback is